So there are people in the room. What is the probability for at least two of them have the same birthday? I have seen the question like this many times. There's usually a very specific number of people in the room, like say 10 people, 20 people, 30 people, 40 people in the room. What is the probability for at least two of them have the same birthday? But I'm looking for a general solution for the problem like this. So I use a random number variable like R. So R people in the room. So R can be any number. So what is the probability for at least two of them have the same birthday? So let's find a solution for this question. So okay, so R can represent people, the number of people in the room. And there's another parameter we need to think about is we look for the same birthday, right? So options of a birthday. Okay, so we have limited options of birthday. Actually, I would say 360, 365, or 366. Okay, so your options for birthday is limited. It's not unlimited. So we use a variable to represent those two things. So first step, so we need to calculate all circumstances. Okay, all circumstances means I can have a birthday like your birthday. We share the same birthday, or your birthday is different from mine. So different people have different birthdays. So how can we calculate all the circumstances? So we know that there are people in the room, right? So we use this little bar to represent R people. So R, we don't know how many R is. Okay. So first person, how many options of birthdays the first person can have? So n, because there are n days in the year, right? So we use n to represent the days, the options of birthday. We don't need to plug in the specific number for now. How about for second person? Same thing, n, right? So that means the second person can have the same birthday as the first person, right? Third person, same thing. The fourth person, same thing. And keep going. For the odd person, for the as person, okay, so the number R, same thing, n. So now we know that for the circumstance, all circumstances, how many circumstances we can have. It's n component R, right? So it's actually a permutation problem without restrictions. Okay, so permutation without restriction or restrictions. Okay, so it's n R component. Now we also need to consider the other things. People do not have same birthday. Okay, that means every person has a different birthday. So how can we do that? That means people have no same birthday. Okay, we still have our people. Okay, if for the first person, the person has n options. For the second one, because the second person cannot have the same birthday as the first person, should be n minus 1, one less of option. Okay, then the third person cannot have the same birthday as the first and second one, so n minus 2. The options are getting less, right? N minus 3. Keep going. What is how many options does the odd person have? N minus r plus 1, right? Okay. So we get a formula. What is the formula for this one? N permute r is actually the permutation with restriction because we don't want to see the repetition. Permutation with restrictions. Okay, all right. Now, step 3. So what's the difference between the two? That means the difference is should be the people have same birthday, right? We have all the circumstances. This is a space. Okay, this is a universe. All circumstances. 1 is all circumstances, and 2 for the people have no same birthday, and we can use these two results or two outcomes to calculate people have same birthdays, circumstance for people have same birthdays. Okay, the circumstance for people have same birthdays. It may be 2 people have same birthday, it may be 3 people, maybe 4 people, but any circumstance, we can it's just calculated like this. All circumstance 1, right, have no same birthday 2. The difference should be the circumstance of people have same birthday. It should be 1, it's nr, okay, minus n permute r. So this difference is the circumstance for people have same birthdays. Now, the question asks for at least the probability for at least 2 of them have the same birthday, right? We just use the difference divided by all circumstances, we can get the probability. Now the fourth step. 1 minus 2, this should be the 3, right? Over all circumstances is 1. Then we can get the probability for at least 2 people have the same birthdays. It also covers the probability for 3 people, 4 people, and any people have the same birthday. Okay, so n component r minus n permute r over 1 n component r, right? Okay, it cancel each other, so 1 n permute r over n r. Okay, so what is n permute r? Here, right? N permute r is here. So it's n minus 1. Okay, n minus 2, n minus 3. Keep going. N minus r plus 1 over n component r. This should be the formula for general solution. Okay, we can plug into any number of r, okay, into this formula, and we can get the result we want. But for here, we need to see that what is number of n? The options of birthdays. For usually most of the years we have 365, but some of the lunar years we have 366. But for general circumstance, we just plug in 365. It should be good. And the general solution gives us an advantage. We don't need to, we can plug in any number of people in this formula and get the probability. All right. This formula is not straightforward, so we need to get a picture or something, give us a sense, some, we can see it more clearly. Now, this is the formula we get because we know that the n is 365. Okay, we suppose it's not linear, and r is a number of people. Okay, in this room, r can be any number. But we know that if we have 365 people in the same room, 100% there will be people have the same birthday because 366. Okay, pretty sure, because we always have at least 2 people have the same birthday. Now we calculate for 1 people in the room, the probability is 0, obviously. Okay, only you in the room, no other people have the same birthday as you. 5 people, 2.7. 10 people, okay, 11%. 20 people, 41%. 20, okay, so more than 50% is 23. 23 people usually have more than 50% more chance to see another person, not same birthday as you, but at least 2 people have the same birthday. Okay, for 70%, 30 people. Okay, 40 people, we almost 90%. So if we have more than 41 people in the same room, the percentage will go up to 90%. Keep going. So let's imagine how many people in the same room. We can have 99% of, we see at least 2 people have the same birthday. 57. That means 99%. You can see at least 2 people have the same birthday. How many people? You don't need so many. You don't need them over 300 people or 350 people to see that happen. 57 people should be enough for you to find at least 2 people have the same birthday. So we plotted the probability on the right side. Okay, here is a number of people. The vertical is a probability. So we can see that 57 is here. Okay, where is 50%? 50% is here. 27 is here. Oh, 1, 2, 3 here. Okay, as long as you have more than 23 people, okay, more than 50%. All right, I hope this video can give you some sense about how many people in the same room can have the same birthday. Okay, it's a permutation problem, and this model actually can be used in many places. All right, thank you. See you next time.